In the introductory course to Python, we provided information to our scripts by creating variables and passing parameters to our functions with the values that we wanted. This works fine for small scripts, but it's usually not ideal for larger jobs. When processing large chunks of data, it's a good idea to read that data from files. In programming, we work with files all the time. It's such a useful task that most programming languages have the ability to work with files baked into their core set of features. Python's no exception. It gives us file objects, which we can use to read and write to files. To open a file on our computer called spider.txt, we can write this code. What we're doing here is creating a new file object and assigning it to a variable called file. The parameter we've passed to the open function is the name of the file we want to open. In this case, we're assuming the file we want to read is in the same directory as the script we're running, but we can just as easily pass an absolute path to open a file in a different directory. When we open a file, like we're doing in this example, the operating system checks that we have permissions to access that file, and then gives our code a file descriptor. This is a token generated by the OS that allows programs to do more operations with the file. In Python, this file descriptor is stored as an attribute of the files object. The file object gives us a bunch of methods that we can use to operate with the file. Now, with this file object, we can read the contents of the file and print them to the screen. Here we've used the readLine method. It lets us read a single line of the file. Let's call it again, see what happens. Nice. This time we got the second line of the file. So how does this work? Well, each time we call the readLine method, the file object updates the current position in the file, so it keeps moving forward. We can also call the read method, which reads from the current position until the end of the file, instead of just one line. And washed the spider out. Out came the sun and... Wait, don't go. What, you don't like my singing? That's okay. Let's check out the other example. The file here has 6 lines in total. We read the first 2 with our calls to read line, and then the other 4 all together with the call to read. Just like read line, the read method starts reading from wherever we currently are in the file. But instead of just one line, it reads all the way through to the file's end. Finally, we'll close the file using the close method. This open, use, close pattern is a typical way of working with files in most programming languages. It's a good idea to close files after you've opened them for a few reasons. First, when a file is open in your script, your file system usually locks it down, and so no other programs or scripts can use it until you're finished. Second, there's a limited number of file descriptors that you can create before your file system runs out of them. Although this number might be high, it's possible to open a lot of files and deplete your file system resources. This could happen if we're opening files in a loop, for example. Third, leaving open files hanging around can lead to race conditions, which occur when multiple processes try to modify and read from one resource at the same time, and can cause all sorts of unexpected behavior. No one wins in a race condition. Now, I'm going to let you in on a little secret. I'm the worst at remembering to close my files. And you might agree with me, it could get pretty hard to keep track of what files you've opened and then to remember to close them. Fortunately, the creators of Python agree. So, to help us remember to close a file after we're done using it, Python lets us create a block of code by using the keyword with. Let's see what that looks like. As you can see, the with keyword lets us create a block of code with the work we want to do with the file inside of it. In this case, we want to take a line of data from the file and print it to the screen, which is what print file readLine does. When we use a with block, Python will automatically close the file, so we don't need to remember to do that ourselves. Phew. One less thing to think about. Thanks, Python. Both the open, use, close approach and the with approach have their advantages. Using a with block is a good way to open and work on a single file, then have the file automatically close at the end of the block. On the flip side, using open outside of a block means we can use the file object in other places in our code, so we're not restricted to just one single block. But when taking this approach, we need to remember to close it when we're finished. We just took a look at the read line and read methods, which allow us to read a single line of the file or the whole contents of the file right to the end. Along with this, file objects can be iterated in the same way as other Python sequences, like list or strings. This is really useful when you want to process a file line by line. Say, for example, you want to make a whole line uppercase before printing it. You can do that with something like this. Cool. It looks like that worked. But what are these weird empty lines between the contents? Any idea what's going on? What's happening is that the file has a new line character at the end of each line. So, when Python reads the file line by line, the line variable will always have a new line character at the end. In other words, the new line character is not removed when calling readLine. And when we ask Python to print the line, the print function adds another new line character, creating an empty line. What can we do to avoid getting the empty lines? We can use the string method strip to remove all surrounding white space, including tabs and new lines, like this. Awesome! Now that we use strip to remove the new line character, we get the output without empty lines, just like we wanted. Another way we can work with the contents of a file is to read the file lines into a list. Then we can do something with the list like sort the contents. To do that, we open the file and use the readLines method. Let's see how that looks. First, we open the file. Then, read all the lines. And now, we close the file. Even though the file object is now closed, the lines variable has the list of lines in the file, so we can operate on it. For example, let's sort it and print it. There are two things to check out in this code. First, the lines have been sorted alphabetically, so they're no longer in the order that they were in the file. And second, we can see that Python displays the new line character using \n symbol when printing the list of strings. This is a way of explicitly showing that there's a new line character in those strings. In general, to display a character that's not printable, Python uses escape sequences with \, like \n. Another common escape sequence is \t for tab. And we can also use it for escaping quotes if we have a string that contains either a single or double quote. A quick word of caution. Methods like read or read lines that read the whole file at once are useful, but we should be careful when reading the entire contents of a file into a variable of our programs. If the file is super large, it can take a lot of our computer's memory to hold it, which can lead to poor performance. If a file is just a few kilobytes, like in our example here, it's fine to read it and process it completely in memory. But for large files, like a big log file with hundreds and hundreds of megabytes of data, it's more efficient to process it line by line. How's this all sounding? Let's do a quick recap. We've just learned how to open files using the open function and how to read those files using methods like read and read lines. We also learned how to iterate through a file line by line using the read line function and for loops. Up next, we're going to learn how to write content to files. Now that we know how to read files in Python, the syntax for writing to them probably won't seem too strange. Check this out. So, what do we have here? You can see that we're using the with block pattern we discussed in the previous video to open a file called novel.txt. You might also guess that using the write method on a file object writes contents to it instead of reading from it. The second argument to the open method is new though. So, what does the W mean? File objects can be opened in several different modes. A mode is similar to a file permission. It governs what you can do with a file you've just opened. By default, the open function uses the R mode, which stands for read only. You get an error if you try to write to a file open in read only mode. Since read only is the default, we don't have to pass the R as a second argument when we just want to read the file. Writing, however, is a whole different story. The W character tells the open function that we want to open the file for writing only. If the file doesn't exist, then Python will create it. If the file does exist, then its current contents will be overwritten by whatever we decide to write using our script. It's important to remember that when opening a file in write-only mode, you can't read its contents. If you try to, the interpreter raises an error. If you want to add content to a file that already exists, you can do that by using other modes, like A for appending content at the end of an existing file, or R+ for read-write mode, where you can both read contents and overwrite it. This has tripped up a lot of us more than once. So I'll say this again. If you open a file for writing and the file already exists, the old contents will be deleted as soon as the file is open. Yikes. Imagine accidentally deleting important content in a file. So remember, double check that you're opening the right file using the right mode. For example, if you're generating a log file of events that your program came across, you probably want to open the file using append, A mode. Opening it in write, W mode, would mean you'd write over any previous entries in that file. And that's not a good idea for a log file. Or if you're generating a report and want to write it out to a new file using the write, W mode, you probably want to check if the file exists to avoid losing any previous contents. We'll learn how to check if a file exists in an upcoming video. And finally, what's that lonely looking 30 doing hanging out at the end of our code? That's the return value of the write method. When successful, this method returns the number of characters that it wrote. So in this case, 30. In earlier videos, we saw how we can read files, iterate through the contents of files, and also write contents to files. Those are the most common operations we'll do with files, but there's plenty of other things we might need to do when working with files in our scripts. We may need to delete, rename, or move files. Or we might need information about a file, like the time it was last modified or its current size. Let's explore some of the many things that we can do with files in Python. For these operations, we'll be using functions provided by the OS module. This module provides a layer of abstraction between Python and the operating system. It allows us to interact with the underlying system without us knowing whether we're working on a Windows, Mac, Linux, or any other operating system supported by Python. This means that you can write and test a script on one operating system, like Windows, and then run it on a different operating system, like Linux. But one thing to watch out for, paths can be different across different operating systems. So, whenever we're using an absolute path in our code, we need to make sure we can provide alternatives for the platforms we want to support. The OS module lets us do pretty much all the same tasks that we can normally do when working with files from the command line. We can change a file's permissions and delete or rename files through our code. This means you can write scripts to do these operations for you automatically. I bet you're already thinking about how useful the OS module is going to be in your IT role. To delete a file, we can use the remove function from the OS module. Let's see this in action. So, we first import the OS module. Then, we call the remove function the OS module gives us and pass the string novel.txt, which is the file we created earlier. The file's now been deleted. Let's see what happens if we try to remove it again. Fail. If we try to remove the file that doesn't exist, the function will raise an error. We've got a file not found error. The error type's pretty explanatory. And the message also tells us the name of the file we couldn't find, novel.txt. We can easily rename a file with the rename function. The first parameter to the rename function is the old name of the file, and the second is the new name. Let's check it out. Yep, in Python, it's that easy to write a masterpiece. If we try to do this for a file that didn't exist, we'd get a file not found error again. So, how do we check if the file exists or not? There's a submodule inside the OS module for dealing with things related to file information, like whether they exist or not. This is called the OS path submodule. And we can use the exist function in this module to check whether a file exists. Let's try this out with a couple of examples. In this example, the exist function returned a value of true, telling us that the finished masterpiece.txt exists. But userlist.txt doesn't exist, so the function returned a value of false. The exist function is super useful. We can use it to check that a file exists before trying to read it, or verify that it doesn't exist before trying to write it, which helps us avoid losing any data. We saw earlier how to manipulate files with functions like osRename and osRemove, and how to check whether the file exists using osPathExist. We can get a lot more info about our files using functions in osPath module. For example, to check how big a file is, we can use the getSize function, which returns the file size in bytes. To check when a file was last modified, the getMtime function comes in really handy. Let's check out how this works. Huh? What's that long number? It doesn't look like time, does it? That's because it's a timestamp. In this case, specifically, it's a Unix timestamp. It represents the number of seconds since January 1st, 1970. Seems a bit random, right? But there's actually a really good reason behind this date. This was adopted years ago to store the times associated to files in computers. Since that's when they started publishing Unix operating systems, Unix uses that date because there couldn't be any file created before that time. While Unix timestamps have a 50-year history, they're still very much present today. They're used by file systems to show when a file was created, accessed, or modified. They are also used in other systems, like databases. As an IT specialist, you're bound to run into them in your day-to-day. But despite all of that, the number is pretty hard to make sense of. We can use the date-time module to make it easier for us humans to read, like this. Here, we're using the from timestamp method of the datetime class inside the datetime module. It makes the date far easier for us to understand. Remember, the functions in the OS path module take the info provided by the operating system so that we can use it in our scripts, no matter what OS we're running. We can check a file's size or last modification date without having to know the operating system the machine's running, or the type of file system that the file's stored in. Nice, right? Another cool feature of the functions is that we can work with both relative and absolute paths. In our examples, we've been using the relative file names without having to specify their full paths. In some cases, we may need to specify exactly where the file is to work with it in our script. This is where the ABS path function can help. The ABS path function takes the file name and turns it into an absolute path. Python uses the current working directory, which is where the script is being run, to start looking for the file and construct the full path that identifies it. This is useful if we want to store the file's full path or access a file no matter what the current directory is. There's a ton more functions in the OS and OS path modules that let us work with files. But don't worry, you don't have to learn them all by heart. Whenever you need to do something with files, it's a good idea to check the documentation and research what functions are available to find the ones that you need. You'll find a link to the documentation in our next reading. Wow, we're steaming right along now. We've seen how to read, iterate through, and write files. We've then learned how to manage files using lots of useful methods. Now is a good time to try our examples on your computer, or maybe even come up with your own to really get a grasp of it all. If you need to work with files in your scripts, odds are you'll have to handle directories too. For example, you might need to process all the files that are in a specific directory, or generate a directory with the results of your data analysis. As with files, Python provides a bunch of different functions that let us create, delete, and browse the contents of directories. You might remember when we talked about the current working directory, and how important it is to know this when using a relative path to determine the location of a file. To check which current directory your Python program is executing in, you can use the getCwd method. If you use a Unix-like system, you might remember that the name of the command that prints the working directory is called pwd. In this case, the current directory is our user's home directory, which is the default directory we start on when opening a terminal in Linux. To create a directory, we use the makedir function. This function has the same name as both the Windows and Linux commands that do the same exact thing. So, we've just created a directory called new_dir, and it's located in the current working directory. You can also change directories in your program by using the chdir function and passing the directory you'd like to change to as a parameter. Just like the other functions we've seen, we can use relative or absolute paths to do that. As you can see, we've changed the current working directory to the new directory that we created inside the user's home directory. We use mkdir to create directories, and we can use rmdir to remove them, like this. But the rmdir function will only work if the directory is empty. If we try to remove a directory that has files in it, we'd get an error. We need to first delete all the files and subdirectories in that directory before we can actually remove it. But how can we find out what contents are in that directory? Well, there are a few techniques that we can use to do this. The oslistdir function returns a list of all the files and subdirectories in a given directory. Let's see how this looks for a website directory. So, we got a list of strings. Since they're just strings, we don't know if they're directories or files. To find out what they are, we can use functions like os_path_isdir. But before we look at how that works, see how the list contains just file names? If we want to know whether one of these files is a directory, we need to use os_path_join to create the full path. Let's see all of this in action now. This code is doing a bunch of interesting stuff, but let's go through it step by step. First, we're defining a dir variable with the name of the directory that we want to check. This makes our code more readable and more reusable. Then, we're iterating through the file names returned by the os list dir. We know from our previous execution of this function that these are just the names of the files without the directory. So, using os_path_join, we join the directory to each of those file names and create a string with a valid full name. Finally, we use that full name to call os_path_isdir to check if it's a directory or a file. Maybe you're wondering what's up with that join function. It seems to just add a slash between the two strings, right? Well, the join function lets us be independent from the operating system again. In Linux and Mac OS, the portions of a file are split using a /. On Windows, they're split using a \. By using the os_path_join function, instead of explicitly adding a slash, we can make sure that our scripts work with all operating systems. It's another one of those handy little tools that help us avoid errors when working on different platforms. As we called out earlier, there's a lot of functions to manage directories in Python, and we only covered a handful here. We'll learn some others throughout the course as we need them. When we first talked about how to read files, we looked at files with lines of text, one after the other. This is useful in a bunch of different situations, since lots of programs store their state in text files. And we can also handle configuration files and log files as text. But data comes in a bunch of different formats besides text, and you may need to deal with some of these in your scripts. Formats give data structure, and remember that computers love structure and precision. To be able to process a data set, it helps to know ahead of time how that data set will be arranged. If you can expect data to be represented in a certain way, it's easier to extract meaning from it. Let's look at a very simple example. If we have a file that contains one line per machine and details the users that are logged into that machine, then when we read the file, we know how to parse it to get the information that we want. Parsing a file means analyzing its contents to correctly structure the data. We use a bunch of different file formats to structure, store, and transport data. You might be familiar with some already. For example, HTML is a markup format which defines the content of a web page. JSON is a data interchange format commonly used to pass data between computers on networks, especially the internet. CSV, or comma-separated values, is a very common data format used to store data as segments of text, separated by commas. In the Python standard library, you'll find classes and modules for working with many of these data formats, including CSV and HTML. For less common file formats, or more advanced manipulation techniques, you'll find more libraries available as additional Python modules. In the next few videos, we'll check out how we can use a CSV module to process CSV files. This not only shows how we can use Python to work with a specific data format. Knowing how to work with CSV files is a pretty useful skill to know. This format lets us easily store and retrieve information that we might need for our scripts, like employees in our company or computers in our network. In my job as a system administrator, I create CSV files when I want to convert the output of a command into a format that will be easier to parse later on. For example, the df command prints the currently used disk space in a format that's easy to read by human eyes. But turning the info into a CSV makes it much easier to work with the data in my scripts. A lot of programs are capable of exporting data as CSV files, such as spreadsheet applications like Microsoft Excel or Google Sheets. It can actually be helpful to think of a CSV file like it's a spreadsheet, where each line corresponds to a row and each comma-separated field corresponds to a column. So, now that we know what CSV files are, let's learn how to read them. Like we said, CSV stands for comma-separated values. CSV is a pretty simple format. These files are stored in plain text, and each line in the CSV file generally represents a single data record. Each field in that record is separated by a comma, with the contents of the field stored between the commas. For example, if we're storing information about employees at our company, we might store the data like this. Looking at this example, the line that starts with Sabrina is a data record, and the name Sabrina Green represents a name field, followed by a phone number field and a role field. Python's standard library includes a module which lets us read, create, and manipulate CSV files. Do you want to guess what that module is called? If you guess CSV, you're right. All these self-explanatory names makes life a lot easier, right? So, we'll be using the CSV module, and to do that, we'll need to import it, like we've been doing with the other modules. Now, before we can parse a CSV file, we need to open the file, the same way as before. And now we can parse this file using the CSV module. Okay, that's given us an instance of the CSV reader class. We can now iterate through its contents and access the information that it parsed. Now, the row variable will hold each row in the CSV file. This variable is a list, with each field in the CSV corresponding to one element in the list. We know from before that the first field is the name, the second one the phone number, and the third the role. So we can unpack the values so that we can use variables to refer to them. Remember that for this to work, we need to have the exact same amount of variables on the left side of the equal sign as the length of the sequence on the right side. Now that we've unpacked these values, let's print them to the screen. As we mentioned, we unpack the row so that we don't have to use indexes to access each element in that list. For example, we could have used row 0 to access the name of the employee. This is valid, but it can be hard to follow when reading a lot of code. Unpacking the list into named variables makes the code easier to understand later on. And before we forget, let's close this file now that we're done with it. Pretty useful, right? With that, we've now learned how to read and iterate through CSV files. Up next, we'll talk about how you can generate your own CSV files. In the last video, we used the reader function from the CSV module to read the contents of a CSV file. Similarly, we can use the writer function to generate contents to a file. This can be really helpful if you process some data in your script and you want to store it in a file. Maybe you want to import it into a spreadsheet or use it later on in your script. We'll start by storing the data that we want to write into a list. We've created a list of lists. This is the data that we want to store in the CSV file, representing the names of the machines in our network and their IP addresses. All right, with that data ready to be written, let's open the file in write mode. We'll use the with block that we saw before, so we don't forget to close the file. Okay, now that we have the file open for writing, let's call the writer function of the CSV module with this file as a parameter. The writer variable is now an instance of the CSV writer class. There are two functions that we can use: write row, which will write one row at a time, and write rows, which will write all of them together. In this case, we already have all the data that we want to write, so we'll call write rows. Nice. With that, we've written our data to the CSV file. Before we move on, let's see how this looks when we use a tool outside of Python, like the cat command. All right, our code worked and we generated a CSV file with the data that we wanted. Nice work. We're on a roll, so let's keep going. In our earlier examples, we saw how we can read and write CSV files, and we use list as a data type on the Python side. This works when we know what the fields are going to be, but it can be pretty cumbersome when we have a lot of columns and we need to remember which is which. Imagine if your list of employees not only had name, phone number, and role, but also start date, username, office location, department, preferred pronouns, and so on. It would soon get hard to keep track of which column corresponds to which position in the row. For cases like this, it's common for CSVs to include the names of the columns as the first line in the file, like in this example. This CSV file lists a bunch of internally developed programs used at the company, including the latest version, the current development status, and the number of people using it. Check out how the first line of the file includes the names of each of the fields. We can profit from this additional information by using Dictreader, a slightly different reader that's also provided by the CSV module. This reader turns each row of the data in a CSV file into a dictionary. We can then access the data by using the column names instead of the position in the row. Let's see how that looks. So here, we're opening the file and creating a dict reader to process our CSV data. Then, when going through the rows, we can access information in each row using the keys, just like we would when accessing data in the dictionary. See how we use row name and row users to get the name of the number of users? Let's execute this and see what happens next. As you can see, we've successfully printed the contents of the two fields that we wanted. Two important things to call out here. One, the order of the fields in the file doesn't matter. We can just use the name of the field instead. And two, Chatty Chicken is still in alpha, so only has 4 users. But you know, with a name like that, it's going to be a hit. So we can use Dictwriter in a similar way to generate a CSV file from the contents of a list of dictionaries. This means that each element in the list will be a row in the file, and the values of each field will come out of each of the dictionaries. For this to work, we'll also need to pass a list of the keys that we want to be stored in the file when creating the writer. Let's see this in action. First, we need a list of dictionaries with the data that we want to store. For this example, we want to store data about the users in our company and the departments that they work in. So, here we have our list of dictionaries, and each contain the keys name, username, and department. We now want to write this to a file, and the code will look like this. So, we first define the list of keys that we want to write to the file. Then, we open the file for writing. Next, we created the Dictwriter passing the keys that we had identified before. And then, we call 2 different methods on the writer. The write header method will create the first line of the CSV based on the keys that we passed. And the write rows method will turn the list of dictionaries into lines in that file. Let's check if this worked correctly. All right, we successfully generated a CSV from our dictionary. Nice, right? Let's take a moment to acknowledge everything you've learned about managing files over the last few videos. You can read, write, and work with files and directories. And now, you can also read and write CSV files.
Congratulations on finishing this lesson in the Google IT Automation with Python certificate. Access the full experience, including job search help, and get the official certificate by clicking the icon or the link in the description. Watch the next lesson in the course by clicking here, and subscribe to our channel for more lessons from upcoming Google Career Certificates.